Welcome to a new section of the course. In this section, I'll introduce some of the important statements in SQL. We'll start by defining what a database table is, and then we'll also create one of those tables. We'll then add some data to the table. I'll take you through the option of adding a single record as well as more than one record at once. We'll then look at how to read the data from the table once that's being written. It's important to be able to make changes to the data that's already being written. So we'll look at update statements for that next. We'll then look at how to delete any unwanted data from the tables, and also how to remove an entire table if that's not required any longer. Along the way, I'll introduce some of the best practices to help with writing production quality SQL. And as I said before, I believe in learning by doing. So each lesson will be backed up with a practice coding exercise in which you will follow along with what's being learned. At the end of this section, I'll also give you some challenges to test your knowledge and help you gain confidence with this section of the course. By the end of the section, I hope you will have an initial understanding about SQL and some of its capabilities. Let's get started. Welcome back. In this lesson, I'll give you a quick introduction to SQL. SQL stands for Structured Query Language. You may also hear SQL pronounced as SQL. It's a programming language specifically created to interact with relational databases. That definition may seem a bit too simple, and you may want to understand a couple of terms better. Firstly, even though SQL is a programming language, it's a specific type of language called domain-specific language. I'll explain what a domain-specific language is shortly, but some of you may not be familiar with the term databases. So let's start with a high-level overview of databases. Databases are used to store data in an organized manner, and also they provide us with the capability to interact with the data as and when required. As you can imagine, data is everywhere. Data refers simply to any piece of information. For example, you are a student on my course. That's a piece of information important to me. I may want to keep a list of all the students enrolled in this course to help with my interactions. Similarly, you might have taken a number of online courses similar to this one. Again, that's a piece of information important for you. Data can even be as simple as a shopping list or a to-do list. They're all information or data that has value. So you might want to keep that information somewhere. My to-do list and the shopping list could be very small, so I might write them down in a physical notebook. You may want to keep the list of courses you're taking in a text pad in your laptop or mobile phone, as it's probably just a few entries. Assuming I have hundreds of students enrolled in my course, I may choose to keep the list of students in a spreadsheet. This gives me the ability to search and analyze the data quickly. For example, I'll be able to quickly find all the courses a particular student has enrolled in. Also, I can calculate the total number of students in a week, month, etc. I could simply update the spreadsheet manually every day. My spreadsheet may contain the student's personal details such as name, address, date of birth, etc. It may also contain information about the courses they have enrolled, the date of registration, and also it may have the student's credit card details using which the payment was made and the payment amount and so on. Imagine the course becomes popular and I get tens of thousands of students registering the course. It'll be impossible to manually capture this much information on a daily basis. So I may have to allow for my website to be able to directly update the spreadsheet every time a student enrolls in the course. Also, legally, I need to restrict access to this spreadsheet and keep it secure as it contains the personally identifiable information of my students as well as their credit card information. I also should be able to enable access to more people in my team to be able to concurrently access the spreadsheet so that they can use this data effectively for marketing and reporting purposes. Spreadsheets enable some of these capabilities such as shared access, password protection, etc. But it's far from what we need. This is where databases come in. They let us store large amount of data. We can define the security required so that only the authorized users or applications are accessing the data. They also enable concurrent access to the database tables so that multiple users can work on the same data. and they offer many more benefits such as data integrity, automated backups, quick access to the data, etc. Databases store data in the form of tables organized as rows and columns. But how do we access the data stored in a database table from a web application or as an individual user? That's where SQL comes in. SQL is a programming language specifically developed to interact with databases. But you might be wondering, how does a storage system such as a database understand a programming language such as SQL? You're not alone. A lot of people consider databases to be just a data storage solution. But there are two components in a database. The first one is the storage, which keeps the data we want to store, and that's what most people are familiar with. But it also comprises of another component called Database Management System, or abbreviated as DBMS. This is simply a software component, and that is the brain behind the database. It has many functions, such as processing the SQL statement being sent to the database to get the right data, managing access to the database, taking backups, optimizing the SQL statements to get the best performance, etc. We'll commonly refer to both of these components together as a database. Also, please note that when you're working with relational databases such as SQLite, MySQL, PostgreSQL, Oracle, etc., the database management system is referred to as Relational Database Management System, or RDBMS. Now that we understand what a database is, let's quickly talk about SQL. SQL is a domain-specific language specifically designed to work with databases. The opposite of domain-specific language is the general-purpose programming language, examples of which are C, C++, Java, etc. A general-purpose programming language can be used to perform a variety of tasks, whereas a domain-specific language is specifically developed to solve a specific problem. In this case, SQL is specifically developed to interact with databases. Another example of domain-specific language is HTML, which was specifically developed to create web documents. Even though domain-specific languages are limited in functionality, they have a major advantage that they're easier to learn and use, and SQL is no exception. In summary, SQL is a domain-specific programming language created specifically to interact with relational databases. You might now be wondering whether learning SQL on a specific database is sufficient to work on another database. The answer is broadly yes. Most databases adapt the standard for SQL defined by the American National Standards Institute, or ANSI, with some minor variations. So once you learn to work with SQL on one of the databases, you will be comfortable working with the others. Of course, there will be some small differences, but you will be able to easily work with them. Examples of some of the most common databases are PostgreSQL, MySQL, SQLite, and SQL as shown here. You can even use SQL to work with big data technologies as well as NoSQL databases, as most of them nowadays offer a SQL endpoint. I hope you now have a basic understanding about SQL and databases. In the forthcoming lessons, we'll delve deeper into its capabilities. And that's the end of this lesson. I'll see you in the next one. Welcome back. As we saw previously, a database can be used to store data. The data in the databases are stored in an object called table, and a database can have one or more tables. The data in the table is organized as rows and columns, which is very similar to how we store data in a spreadsheet. A database table also offers some important additional features over a spreadsheet. But having said that, most of you would be familiar with spreadsheets. So to make it easier to understand, let's start by looking at how the data is organized in a spreadsheet and see how that relates to a table in a database. This spreadsheet has a number of sheets, and we're now looking at a sheet called population, which contains the population of the top 10 most populous countries in the world. We have the name of the columns at the top, which are country and total population. We then have 10 rows of data with 2 columns each. The first column contains the name of the country, and the second column contains the total population in each of those countries. As you can see, I have formatted the first column country to be text and the second one total population to be a number. A database table also organizes data in the same way. To keep it simple, let's exclude the data from the spreadsheet for the time being and focus on the properties of the sheet and map them to the properties of a database table. Each sheet name in a spreadsheet corresponds to a table name in a relational database. And column names in a spreadsheet are also called column names in a database table. But instead of column formats, they are referred to as data types in a database table. Unlike a spreadsheet, the data type in a table is defined at the time of table creation, and the data populated to the table must conform to the data type specified. For example, you can't define the data type of total population to be a number and then add text data into it. The database will reject any such data. Let's now see how to create an equivalent database table for this spreadsheet using SQL. In order to create the table, we need to use the create table statement in SQL. This is then followed by the name of the table, followed by column name and data type within parentheses. Please note that there is a blank space required between the column name and the data type. Also, if you have more than one column, like we do in this example, we can list the other column names and the data types separated by a comma, but the comma here is quite important and it informs the database to expect another column in the list. Now that we understand the properties of the create table SQL statement, let's try and come up with the SQL statement required to create a table for the population data. As you know, we want to keep the table name as population, so I have replaced the table name with the word population. And we have two column names, country and total population. You may notice that I have added an underscore between total and population for the second column name. If you want to have spaces in the identifiers such as column name, you will have to quote them. But having spaces in identifiers is highly discouraged in most programming languages, including SQL. So please use underscores to make the names readable instead of using spaces. SQL offers a number of data types. We know the country is a string and the total population is a number. So I have used the equivalent data type for country as varchar 50, which is a type of string, and total population as int, which is the short form for integer. These data types could be new to you as we haven't talked about data types yet. We'll go through data types in detail in a later lesson, but briefly, varchar stands for variable character and varchar 50 can hold up to 50 characters. And int or int is the data type that can hold whole numbers such as population of a country. Finally, SQL uses semicolon as the termination character between statements. As this is the end of the SQL statement here, let's add the semicolon to terminate this statement. Running this SQL statement will create the table population with the columns and the data type specified. Please note that this is the most simple form of creating a table in a database. Databases offer a lot more properties that I'll slowly introduce in later lessons, but here I wanted you to get started as easily as possible. Let's now switch over to the database and start creating this table. Here we are in the SQL Studio and let's create the table. As we discussed, we need to start the SQL statement with the keyword create table. This is then followed by the name of the table, which is population in our case. And then we need to specify the column details within brackets. So let me add a set of brackets here. And we want to specify the column details within the brackets. And the first column we've got is country. And the data type of the country we want to keep is varchar 50. And at the end of this line, we need a comma because we've got another column in the list. And the second column is total population. And the data type of total population is integer, so that is int, and that's everything we need within the create table statement. And we can now terminate the SQL statement with a semicolon. As we've completed right in the SQL statement, let's execute it and see whether the table gets created. As you can see in the status, this query has finished successfully. That means the table's created. That is great, but you might be wondering why I have part of the SQL statement written in uppercase and the others in lowercase. Also, when to use new line characters and spaces and things like that. And I'll take you through all of these in the next lesson. I'll see you then. Before you start writing your first SQL statement, I would like to take you through some best practices. It's really important to get used to these best practices early on so that you are equipped to write code which is easy to read and maintain. As you know, we wrote this SQL statement in the previous lesson to create the table population. It's written over 5 lines with some formatting and indentations. But none of this is necessary when writing SQL statements. The same statement can be written like this with all the column details in one line and the rest in another. Also, you can write everything in one line like this. You can even write the same SQL like this with all the characters in lowercase and the entire statement in one line. Database management systems ignore new line characters and additional white spaces, and also keywords can be written in both uppercase or lowercase. So both of these statements represent the same thing. But as you can see, it's so much harder to read the bottom statement when it's all written in one line without any indentation or casing. This gets even harder when you have large SQL statements. So it's really important for us to follow some best practices so that we can write production quality SQL statements which are easy to understand and maintain. Let me take you through some of the common standards followed in the industry and what I personally prefer. Please feel free to adopt as you wish. Firstly, every SQL statement will have some keywords. Keywords are generally words that have significant meaning in SQL. In this example, create table is one such keyword which instructs the DBMS to create a table. Also, varchar and int are informing the database management system to use specific data types. Keywords in SQL are case insensitive, but common practice is to use uppercase for them. Secondly, every SQL statement will have some identifiers. An identifier in SQL is simply a name of the database object. In this example, population is the name of the database object called table. Similarly, country and total population are names of the database object called column. Depending on the database configuration, the identifiers can be case sensitive in some databases, but it is recommended to use lowercase for identifier names with an underscore to separate words for readability like we have done here. In terms of formatting, I would recommend you to have one item per line. For example, as shown here, keep one table, one column in a line so that it's easier to read. And finally, make sure to indent the code so that everything that needs to be considered together are aligned. In this case, that's all the column names and their data types. Applying these basic rules makes your code so much readable and understandable. And also, similar to other programming languages, SQL also offers comments. Comments enable the developer to document any important information required to maintain the SQL script. The most common form of comment you may see is this one. It starts with a dash dash, followed by the text of the comment. But this comment cannot extend to a new line. It's most commonly referred to as a single line comment. SQL also offers multi-line comment as shown here. It begins with the characters slash and an asterisk and ends with an asterisk and a slash. Everything in between is considered as comment and ignored by the compiler, and the comment can span multiple lines. You can also use this for the single line comment as shown here if that's your preference. Comments are quite useful to document the SQL scripts, but please use them wisely. Having too many comments can also make your scripts unreadable. You may have just started your journey on writing SQL, but please make sure to add comments as necessary and format the code from day one so that you enjoy writing SQL like I do. That's everything I wanted to cover here. I'll give you more best practices later on in the course. But before we finish, let's switch over to the database and add some comments to our script. Here we are in the SQL Studio. Let's add some comments to our SQL script. I'm going to start with the multi-line comment at the top of the script. So I'm going to simply say that this script contains all the SQL statements from this section of the course. So I've started with a slash and a star, and then I'm going to write my comment here. And I'm going to simply complete the comment with a star and a slash. And that's a multi-line comment, as you can see. So we've got that at the top of the script. We can also use single line comments as we discussed, and that starts with a dash dash. So let me simply say I'm demonstrating the create table statement here. And also you don't necessarily have to have the comment starting from the beginning of the line. You can have it at the end of a statement as well. So for example, if I wanted to add a comment at the end of this line here, I can simply say dash dash, and then I can add a comment. For example, I can say country names are expected to be a maximum of 50 characters. So let me just do that. So that's how you add comments there. These are quite useful as well. So you can quickly add a comment to one of the lines and then carry on. You're not taking up another line and making your scripts longer. So that's everything you can do with the comments. And as I said, it's better to indent all your code. So I'm going to simply indent my data type here as well. That's all I wanted to show you. I hope you've now got a good understanding about how to use comments and how to indent your code and make it more readable. And that's the end of this lesson. I'll see you in the next one. Now that we've created the table population with the columns, country, and total population, it's time to think about how to get data into our table. SQL offers the statement called insert to populate the table. The syntax for the insert statement looks like this. It starts with the keywords insert into, followed by the name of the table. It's then followed by the list of column names in the table, then the keyword values, followed by the list of values for the columns. We can then terminate the statement using the character semicolon. For example, to populate the table population, we need to write insert into population. Then we need to list the column names. As you know, the column names in our table are country and total population. We then need to provide the values for the country and total population. Let's assume that we want to insert the total population of India. India will be the country and 1.42 billion will be the total population. That goes into the values clause. When executed, this statement will simply insert the first record into our database table population as shown here. You may notice that I have used the single quotes around the country name India in the insert statement. This is because country is a string data type and single quotes are used to indicate the beginning and the end of a string in SQL. Most databases also lets you use double quotes, but it is recommended to use single quotes. Now that we understand how to write an insert statement, let's go over to the database and try to execute this code. Here we are in the SQL Studio. Let's insert the population of India into our table. As you know, the insert statement starts with the keywords insert into, followed by the name of the table, and we need to list the column names. So I'm going to specify the column names here, which is country, total population. And we need the keyword values here, and we need to specify the list of values. So we need to specify the country first, and as we discussed, we need to give the name of the country in quotes because it is a string. So I'm going to say India within quotes, and we need to specify the total population. That's about 1.42 billion. And let's close that bracket and add the semicolon to terminate the statement. And that's all we needed to do. So let me execute this statement. And as you can see, the query has finished and the number of rows affected is 1. That means 1 record has been inserted. And you might be interested in seeing the data that's been inserted into our table population. And how do we do that? SQL offers a statement called select statement to do that. I'll take you through select statement shortly, but let's just run the statement select star from population to see the data in the table. Let me execute that. And as you can see here in the results, we've got the country as India and total population as 1.42 billion. And that's the only record we've got in the table. As I said, I'm going to take you through select statement in detail later, but all you need to know at this point is running select star from a table will output all the data from the table to you. Before we finish, I want to take you through a couple of other forms of insert statement. You can specify the column names in a different order. For example, total population first and country second. But the values have to match the column order. Otherwise, the database will try to insert total population into country and vice versa, which will result in failures. So we need to specify the population value first in this example and then country second like this. Execution of this statement will insert the population of India into the table. It's also equally valid to omit the column list from the insert statement. If you omit the column list, the database engine will take the column list from the table definition. So the order of values will have to match the table definition. As you know, our table definition has country first and total population second. But this insert statement has the values the other way around. So if we execute this statement, it will try to insert the total population into country column and the country name into the total population column, which is not what we want. So in our example, country has to be the first value and the total population has to be the second value. This insert statement will successfully execute and insert the total population of India into the table. Having said that, I strongly recommend specifying the column list. This is for two reasons. Firstly, it makes it obvious for someone looking at the code to know which columns are populated by this SQL statement. Secondly, if someone adds an optional column in the middle of the table at a later date, our code will still work without any changes. It will simply not populate the optional new column. So please try to use column list in your insert statements so that it's obvious. I hope you now have a good understanding about inserting a single record into a database table. And that's the end of this lesson. In the last lesson, we inserted a single record with the population of India into our table. But as you know, we still have 9 more records to insert into the table. It'll be tedious to write that many insert statements and execute them one by one. Instead, SQL offers us the ability to write one insert statement to insert more than one record. And that's what we're going to look here. For example, to insert the population of both China and United States, we can simply write one insert statement. The first part of the insert statement looks exactly like the ones we've seen before. This will just insert the population of China into the table. To insert both the population of China and United States, we simply have to add the values related to United States to the end of the statement like this. Please note that there is a comma at the end of the first set of values. If you don't specify the comma, you will get an error. This will insert the data for both countries into our table. You can also add all the other countries to this list by separating the values by comma. Let's now switch over to the database and I'll show you this in action. Here we are in the SQL Studio. Let's insert the population of other countries into this table. As we said, the insert statement looks exactly the same as the previous one. It starts with the keywords insert into, followed by the table name, which is population, and we need to specify the list of columns, followed by the keyword values, and then we specify the first set of values here. In this case, it's going to be China, and the population of China goes here. And at the end of this line, we need a comma because we're going to have another country here. And the values for the other country goes here, which is United States. And let's give the population of United States here. And this will insert the population of both China and United States into our table. Whilst I'm here, I'm going to add all other countries as well, so that I've got one insert statement to insert the population of all the remaining 9 countries as well. Let's terminate the SQL statement with a semicolon as well. And let me execute this insert statement. And as you can see, the query has finished successfully and it's added 9 records. So if I just run the select star from the population table, I'll see all 10 records. So let me run that. And as you can see here, I've got 10 records in here with the population of all of those countries. So that's quite cool. As you can see, we've got one insert statement which inserts the population of all countries into this table. So I hope you've now got a good understanding about how to insert multiple records into a table using an insert statement. And that's the end of this lesson. I'll see you in the next one. Welcome back. We now have the table population populated with the 10 countries and their total population. This is great, but it's only useful if the consumers of the data can read this information and analyze the data as required. We can do this by using the select statement offered by SQL. If you have come from a traditional programming language background, you might refer to this as reading the data. But in SQL, executing a select statement is referred to as querying the data. So that's the term we will be using for the rest of the course. A simple select statement has a select and a from clause. In the from clause, you specify the name of the table, and in the select clause, you specify the name of the columns from which you want to select the data. When writing select statements, I prefer starting with the from clause and then progress to the select clause. As you can imagine, logically, you would be finding the table from which you want to get the data first, and then you will identify the columns that you are interested in. I find writing SQL statements in the same way to be quite intuitive and easier when especially dealing with multiple tables. But please feel free to do whatever works for you. As we know, we want to select the data from the population table. So let's replace the table name with population. And we know this table has 2 columns, country and total population. Let's assume that we just want to get the list of countries. In this case, we just need to replace the column name as country in the select clause, as you can see here. Executing this query would result with list of country names as shown here. If we also want to get the total population, we just have to add total population to the column list. But please remember to separate the column names with comma. The result of this query would look like this. But sometimes when you're doing quick analysis of the data in a wide table with multiple columns, listing all the column names might become a bit tedious. In those circumstances, you can use the wildcard character star instead of listing individual column names. Star is equivalent to all, and it brings back all the columns from the database table. We have already seen this in the previous lesson. By executing this SQL statement will give you both columns from the table. Feel free to use star when doing quick analysis of the data, but using star is not recommended for production projects due to 2 reasons. Firstly, it's not obvious for someone looking at the SQL to know which columns are being selected. They'll have to describe the table to see the list of columns in the table to know that information. Secondly, if a database administrator adds an additional column to the table on a later date, that could break an application that's trying to select the data using select star unless the application code has been changed to expect the new column. For example, a web application might not be expecting the new column being added, and if you use a star instead of column names, the database will return all the columns including the new one. This could break the front-end application. But specifying the column names in the select statement avoids this issue. So please don't use star for production applications, but feel free to use it for ad hoc analysis. Now that we have an initial understanding about select statements, let's see them in action. Here we are in the SQL Studio. Let me demonstrate select statements. We've already seen how to use select star on a table, so we won't repeat that, but let's look at the other variations. Let's say we want to select the countries from the population table. For that, you would write the select statement as select, country as the column name, and then you would go from the table, which is population. You also need a semicolon at the end because that's the terminator for any SQL statements. And let's execute this one. And as you can see, it's listed all the 10 country names here. But if you wanted to also have the total population, you simply have to add a comma at the first end of the first column, and then you would have to add the other column name. In our case, it is total population. And when you execute this statement, you're going to get the result with the country and the total population, as you can see here. Instead of this, if you wanted to see the total population first and then the country next, you can do that as well. You simply have to swap the column names around in the select statement. So let me do that. So I'm going to bring the total population as the first column, and then I'm going to have a comma at the end of it, and the second column is country. So let me paste that as well. And if I execute this, I'm going to see total population first and then country next. You can do many more things with select statements, but I hope this has given you an initial understanding about select statement. Select is one of the widely used statements in SQL, and as I said, it has many more features than this. So we have a separate section just to focus on select statement. I'll take you through more details in there, but that's the end of this lesson. I'll see you in the next one. In the last lesson, we looked at reading data from a table using the select statement. We displayed all the data from this table. In this case, it's a very small table with a handful of records. So it's okay, and we could make sense of all of the data at once. But when you have a large table with millions of records, you would want to specifically look at a particular record or a few records. For example, you might want to see the total population of just one country, or you might want to list all the countries with a population of more than 1 billion. SQL gives us the where clause, which could be added to the select statement to filter the result set as required. We saw the select statement with the from clause in the previous lesson. We simply have to add the where clause to this with the condition required to filter the data. Let's see an example using the data we already have in the population table. Let's say we simply want to get the total population of just one country, which is China. We write the query as select total population from population, and then we need a where condition to filter only the record with country as China. For that, we just have to add the where clause with the condition country equals China. Please note the quote around China. As we discussed before, strings or characters will have to be quoted. Running this SQL query will give us the total population of China alone, as you can see here. Please note that here we've used the equals condition in the where clause, but there are a number of conditional expressions available, including less than, greater than, etc. Also, you can have multiple conditions using and or operators. We'll take a look at them in detail in the forthcoming section of the course, but let's now switch over to the SQL Studio and see this in action. Here we are in the SQL Studio. Let me demonstrate how to use where clause in a select statement. And let's say I want to get the total population of Russia in this select statement. So I start with the select statement. I'm going to list the column name that we're going to get the data for, which is total population. And we want to list the table name here, which is population. And we need a where clause, as we discussed. So that'll be where. And we need to specify the country from which we're getting the data for. So in this case, country equals Russia. So as we discussed, strings will have to be quoted. So I'm going to have Russia within single quotes, and let's terminate this select statement as well. And if I execute this, I should get the total population of Russia. As you can see, I've got the total population of Russia in the result. That's great, but you might be wondering why I have added blank space on each side of the equals symbol here. That's not necessary, and removing that doesn't make any difference, and SQL simply ignores that blank space. The only reason I have added the blank space is to make the SQL statement more readable. You will see this kind of approach widely used in the industry, so I would encourage you to do that as well. And that's the end of this lesson. I'll see you in the next one. Insert statement helped us insert new data into our table. But how do we carry out updates to the data that's already loaded into the table? From time to time, we may have to update data in the tables because the data already in the table is incorrect and we want to update the information, or we may have received new information and we want to update that in our table. For example, we may have received the most up-to-date population of a country and we want to update the table with the new population data. SQL offers us update statement to do this. It starts with the keyword update, followed by the table name that needs updating. It then is followed by the keyword set, in which we specify the name of the column for which the data needs to be updated and assign that with a new value. We can then optionally follow that with a where condition. Where condition is optional, but please be careful. If you don't specify the where condition, every single record in the table will be updated. So most of the time you will see a where condition. That's because you may want to specifically update only certain records. In this statement, we are updating only one column with a new value. You might be wondering, how do we update multiple columns in a table? You simply have to add those assignments to the set class as shown here, but please remember to add the comma after each set of assignments. Let's now take a look at a practical example to understand the update statement better. Let's say we've received the updated population information for United States and we want to update the table with the new figures received. As we said, we need to write the update statement with the keyword update, followed by the table name, which is population in this example. We then need to identify the record to be updated. In our example, we want to update the record where the country is United States. So let's add the condition in the where clause. It'll be where country equals United States. And finally, we need to set the new value for the column total population. We do that in the set statement. When we execute this statement, the total population of the United States is updated with the new value for the total population. You may have noticed that I approached this update statement not sequentially. I first identified the table, I then approached the where condition, then the column to be updated. This makes logical sense to me, and this is how I would approach updating a specific record manually in a spreadsheet, for example. First, I would find the sheet where the data is. I'll then locate the record to be updated and then apply the update to the specific column. Approaching like this makes it a lot easier to write the SQL statement as well. And I see most people in the industry doing this way, but please feel free to take an approach as you find easier for you. Now that we understand how to write an update statement, let's see this in action. Here we are in the SQL Studio. Let me now demonstrate how to write an update statement in SQL. As we discussed, let's say I want to update the total population of United States with a new value. Before we write the update statement, let's run a select to get the current population of United States in our table so that we know it's been updated once we run the update statement. We now know how to write select statements, so let me quickly write a select statement to get the total population of United States. As you can see, the population of United States is just under 340 million. Let's update this with a value slightly higher than this. So we know to write an update statement, we'll have to start with the keyword update, followed by the name of the table, and then we need the set statement here. But before we do that, let's filter the data. So we need to write a where clause here to filter the country as United States. So here I've just specified where country equals United States, and we want to set the population to a different value. So I'm going to say set total population equals, and let's go for 341 million. Okay, let me terminate this SQL statement and let's execute that. And as you can see, the query is successfully finished and it's updated one record here. And if I rerun this select statement now, we should see that value. So as you can see, the new value of total population for USA is 341 million in our table. So updating a table is as simple as that. And as I said, if you omit the where clause, every single record in the table will be updated. So that means the population of every single country would be updated with the new value we've specified here. And this is not what we want. That's why where clause in an update statement is really important. That's the end of this lesson. I'll see you in the next one. Similar to updating data, there are circumstances in which you may want to delete data from a table. For example, when you receive the population data for all countries next year, you may want to delete all the data in this table and insert the new data so that there are no duplicates. Also, you may want to delete individual records because they're no longer relevant or you have added them incorrectly. SQL offers a delete statement to do this. It starts with the keyword delete, followed by the from clause, and then the table name from which the data needs deleting. You can optionally add a where clause to filter specific records to be deleted. Where clause here is optional, but please be careful that delete statement without a where clause will delete all the records in the table. Let's take a practical example. Let's say we want to delete the record for the country Russia from our population table. As we said, we need to write the delete statement and specify the table name as population in the from clause. We also need the where clause as we are deleting just the record for Russia, and the where condition will be country equals Russia. When you execute this statement, the record relates to Russia in the population table will be removed. I just want to reiterate that, as we said before, if we omit the where clause, every single record in the population table will be deleted. So please be mindful of that. Let's now switch over to the SQL Studio and I'll show you this in action. Here we are in the SQL Studio. Let me demonstrate deleting data from a table. And as we discussed, let's delete one record from our table and let's take the country as Russia. So in order to do that, we start with the keyword delete, and then we need the keyword from, and we specify the name of the table. In our case, it's population, and we need the where clause, and in the where clause, we specify the condition as country equals Russia because that's the record we are planning to delete. And if I execute this statement, it should delete the record for Russia. So let me execute that first. And as you can see, one row has been affected in the status here. Let's confirm that by running a select statement in our table. So I'm going to simply run select star from population. And let me execute this statement. And I should only see 9 records here now. As you can see, we've got 9 records in our output, and Russia is missing from the list because we've deleted it. And let me also demonstrate what happens when you delete from a table without a where condition. So I'm simply going to remove the where condition from here, and that'll delete every single record from the table. So I'm going to simply run that. And as you can see, it says the number of records affected is 9. And if I run the select from the table, I've got no records in the output, and we just have the column names listed here. So as I said before, please be careful when you're running delete statements. Make sure to use the where condition where it is appropriate. That's the end of this lesson. I'll see you in the next one. From time to time, you may want to drop an existing table from a database. For example, this could be because the table is part of a short-term use case and you no longer need this table, or this table is created as part of the process which needs the table only for a temporary period. To drop the table, we need to use the drop table statement, which is quite simple, with the keyword drop table that's followed by the table name. Let's say we want to drop the population table. Running the statement drop table population simply wipes out the entire table with all the data from the database. This action is not reversible, so please be sure that you really want to wipe out the table entirely before dropping it. Let me switch over to the SQL Studio and show this in action. Here we are in the SQL Studio. Let me demonstrate dropping a table. And as we discussed, let's say we want to drop a population table. In order to do that, you simply start with the keyword drop table followed by the name of the table, which is population. And let's terminate that with a semicolon. And if I execute that, that should simply drop the table. So as you can see, the query has finished, but in order to make sure that the table has been dropped, we can simply try and run a select statement on the table, and we should really get an error because the table doesn't exist anymore. So let me do that. As you can see, we've got an error saying there is no such table called population in our database. So I hope you now understand how to write a drop table statement and the effect of that. And that's the end of this lesson. See you in the next one.